So, hello everyone. Welcome you all in the problem solving class of the course Applied Electromagnetics for Engineers. I am Vivek Kumar Srivastava, TA of this course. So, in some of our previous classes, we have seen numericals based on the topic lossless transmission line. Then we have seen the numericals based on the lossy transmission line, and after that we have covered some of the prominent numericals that are based on the topic impedance matching network. So basically impedance matching network we have seen so as to visualize that how to match the transmission line impedance to the load impedance, or the transmission line impedance to the source impedance, such that the effect of reflection can be ignored. Okay, such that uh, reflection effect can be completely eliminate. Okay, so after for that we have seen various techniques, that is quarter wave transmission line we have seen. Then we have seen L section matching networks, and after that we have also seen the stub matching network. Okay, then we have seen numericals based on the topic transient analysis of the transmission line. So basically in the practical scenario, what happens is that whenever consider a microcontroller that is used to control the output of any transmission line. Okay, so once we apply the pulse to the transmission line, okay, that is control signal. So sometimes uh, that how the transmission line behaves due to this pulse shaped voltage incident to the transmission line, that we have covered in the uh, transient analysis of the transmission line. So basically for analyzing such a circuit, we have seen bounce diagram that is used. Okay, so as to determine the that what will be the uh, voltage at a particular time instant, and at a particular position of a transmission line, that we have already covered in our previous classes. So the today class is completely devoted to the topic uh, coordinate system and vector analysis. Okay, so let us start. So here is the first question, that is, consider the following statement about three vectors, that is u, v and w. Okay, so here are the four statements, or say four conditions is given. You have to find out that which statement is incorrect. Okay, so the first statement is u dot v is equals to v dot u. So as you all know that the dot product basically resembles the uh, uh, commutative as well as distributive property. Okay, so commutative uh, uh, property says that if suppose you have two vector uh, u and v. Okay, so u dot v should be equals to v dot u. Okay, so this basically said the uh, commutative property, whereas the distributive property said that if suppose you have these three vectors, that is u, v and w, then u dot v plus w is equals to u dot v plus u dot w. Okay, so this is basically a distributive property, whereas one more property which is the multiplicative property of the dot product. So basically multiplicative property states that if suppose this is a constant k and you multiply by a vector u, and this you will dot product by another vector, let us say it's a v. Okay, then this will be equals to u dot kv or ku dot v. Okay, so here you can see that the first statement is same as the commutative property, which is u dot v is equals to v dot u. So this statement is correct, whereas the second uh, statement is somehow similar to the distributive property. Okay, but here you can see that u dot v is correct, but here this will be u dot w instead of v dot w. So this statement is wrong. Similarly, this property is basically the multiplicative property. Okay, so this is also correct here. And this is the null property, that is, if you suppose multiply any vector by a null or say 0, so this will also give a 0. Okay, so this statement is also correct. So the incorrect statement is option 2. Okay, so any doubt in this question, Praveen?
No doubt, sir. It's clear.
Okay, okay.
Thank you.
So the second question is, a time domain reflectometer is used for A. Locating cable fault in a transmission line only. B. To find the nature of mismatch only. C. To locate cable fault and it can also find the nature of mismatch. And option D, none of these. So which one is correct? So can you please tell me?
Option
Any
C.
option C. So yes, this is a correct answer. Basically, reflectometer is basically an electronic instrument that are used to locate the cable fault which occurs in a transmission line, as well as it is used to measure the nature of mismatch also. Okay, so that's why option C is correct. So moving ahead. So this is question 3. So it is state that if P is a unit vector along line L, okay, then the projection of a vector A on the line L is given by. So option A is A dot L, option B is A dot P, option C is L dot P, and option D is none of these. So any idea which one is correct here? Which option is correct?
Option A.
Option A. Okay,
No,
so
option B. Option B. A dot B.
option B you are saying. Okay, so let us see if suppose P is a unit vector along L. So this represents the vector L, and here is the unit vector P. Okay, then the projection of a vector A on the line L is given by, if suppose this is a another vector A, so you have to find out that how much projection of this vector A along this line L you have to find out. So you have to simple take a dot product of A dot P here. Okay, means you have to uh, take dot product of this vector with the unit vector along this line. So this will basically give you the projection of vector A along this line. Okay, so yes, option B is correct answer. So this is the next question. Here the statement says that given f, which is a function of x, y and z, okay, then you have to find out the modulus of gradient of this function at this point, which is given as 1 comma 2 comma 3. So first of all we have to know that what basically a gradient represents. So any idea that what is a gradient is?
No, sir.
Okay, so basically gradient represents the uh, direction of maximum change. Okay, so if suppose this is my coordinate system and you are locating here at this point A. Okay, and you want to know in which direction, uh, here let us suppose that at this point A the temperature is T1. Okay, which represent a very hot temperature. Okay, and you want to uh, find out the direction where you will get as minimum as possible temperature. Okay, so let us say that T2 represents the uh, lowest temperature. Okay, so if suppose you want to find out that in which direction should I move, so as to obtain this uh, point point B such that the temperature will be minimized. Okay, so for finding out this point you have to take the uh, gradient of this function f. Okay, so this gradient is basically represented as del by del x ax plus del by del y ay plus del by del z az. Okay, so if suppose you are standing here and you want to go here, so first of all you have to see that how much distance you have to cover towards the x axis. Okay, so let us suppose till that point you have to go. Okay, so del by del x basically represents that this much change is required, okay, towards the x axis. Similarly del by del y represents the this much change is required towards the y axis. Okay, and similarly del by del z basically represent this much change is required towards the z axis. Okay, so once you take the gradient of this function f, then you will find out the minimum, yeah, say the maximum rate of change. Okay, such that this function can be minimized. Okay, so this basically represents the gradient. So let us now come to the question. So you have to find out the gradient of this function first of all, and then take the modulus of this function, that is the absolute value. Okay, so first of all, for finding out the gradient of this function f, which is equals to xy plus yz plus zx here. So take the gradient of x. Okay, so del by del x ax plus del by del y ay plus del by del z az into this function, that is xy plus yz plus zx. Okay, now you can distribute this function inside this del operator. So this basically represented at del by del x. Okay, xy plus yz plus zx into ax plus del by del y xy plus yz plus zx into ay plus del by del z xy plus yz plus zx into az. Okay, so you have to first differentiate this function with respect to x. Okay, so from here after derivation, you after derivative of this function you will get y into ax cap. Then you have to differentiate the same function with respect to y. Okay, sorry, here this will be z plus y. Similarly here you can get x plus z, and similarly here you will get, yeah, this will be x plus y into az. So now you have to just put the value of x y z as 1 2 3 in this function, and then you have to take the modulus of this function. Okay, so after that you will get this value, that is root over 14. So this is basically the this is how you can get the value of modulus of gradient of this function. So any doubt in this question?
No, sir. Okay.
Okay, so our next question is, a vector from the origin to point A is given as, so this represent, if suppose uh, this is my origin and this represent the vector A. Okay, and this vector A is defined as 6ax minus 2ay minus 4az, and the unit vector directed from origin toward point B. So if suppose this is my point B, and it's the statement said that the unit vector towards the point B is given as, let us represent this as AB. Okay, AB cap. So the unit vector towards this point is defined as AB cap is equals to 2 by 3 AX minus 2 by 3 AY plus 1 by 3 AZ. Okay, so this represents the unit vector toward point B. Okay, after that the statement said that if the points A and B are 10 unit distance apart, so the distance between these 2 points, okay, these 2 points is 10 unit, it is given in the question. Then you have to find out the coordinate of point B, that what is the coordinate of this point B represent. Okay, so for solving this question, what you have to do, first of all you have to see here that unit vector is, suppose this is a vector B, and you have to find out the unit vector towards this uh, point B. Then what you will do, to for finding out the unit vector, you have to simply divide the vector with its magnitude. Okay, so that's how you can get the value of uh, unit vector. Okay, so let us now find out the vector B. So this will be equals to modulus of vector B into AB. Okay, so AB is already given to you, so here you can put the value of AB. So this will becomes 2 by 3 BAX minus 2 by 3 BAY plus B by 3 AZ. Okay, so in the question it is given that the vector A and vector B are 10 unit distance apart. So you can use this statement, that is vector A minus vector B, modulus of these two vector distance between these two vectors should be equals to 10 unit. Okay, so vector A is already given to you, which is equals to 6ax minus 2ay minus 4az. So you can put the value of A here, and B you have already find out in terms of modulus of B. Okay, so you have to take these two vectors, and you have to find out the distance between these two vectors. Okay, then you can find out the value of B, and once you will find out the value of B, you have to put the value of B in this vector form. Okay, so from here you can determine the coordinate points of B, because the initial point is origin only. So the origin is represented at 0 comma 0 comma 0. So whatever vector you will get, the corresponding uh, components of ax, ay and az represent the x, y and z coordinates of vector B here. Okay, So that's how you can solve this question. So let us come to the answer directly. So vector A has already been given to you. Vector B, as I said earlier, you have to multiply the unit vector with the magnitude. Okay, magnitude of this vector B. So this represents the two vector, and then you have to find out the distance between vector A and vector B, which represent the 10 unit. Okay, so here I directly put the value of vector A and vector B. So this is equals to 6 minus 2 by 3 into B ax plus minus 2. Yeah, so this will be plus 2 by 3 into B ay plus minus 4 into minus b by 3 into az. Okay, so you have to take modulus of this vector and then equate it equals to 0. So once you equate this vector equals to 0, so uh, you will get this equation after expanding this equation. Okay, so this, from this equation you can see that it basically represents the quadratic equation. So you have to uh, simplify this quadratic equation and then find out the value of b, which is equals to 11.75 here, and you have to then put the value of b in this vector which I have previously derived. Here you have to put the value of b so as to find out the actual value of vector b here. Okay, so once you simplify this, you will get this vector. Okay, so the coordinate of vector b represents here 7.83 comma minus 7.83 comma 3.92. Okay, so any doubt in this question, Praveen? Okay, so let us move to the next question. So here is the next question. So find the vector component of f that is parallel to another vector g, which is defined as 0.1 ax plus 0.2 ay plus 0.3 az. Okay, so if suppose a vector is given to you f, okay, so you have to find out the uh, uh, component of this vector f along this another vector g. Okay, means you have to find out the component of this vector f which is parallel to this vector g. Okay, so this is basically the a part of this question. So for finding out this a part, what you have to do, see, as I said in the previous question, that once you want to find out that how much projection of any vector in the uh, in some another direction, you have to simply take a dot product of this vector with the unit vector along that direction where you want to find out its projection. Okay, so if suppose uh, here the unit vector along vector g is defined as ag. Okay, so for finding out the component of vector f which is parallel to g, it is defined as f dot ag. Okay, so this represents the component of vector f which is oriented along another vector g, but here you have to find out the vector component. So you have to uh, multiply by the unit vector with this component here. Okay, so that's how you can find out the vector component of f that is parallel to the another vector g. Okay, so first of all you have to find out the value of ag here, or you can simply replace the ag as f dot g divided by modulus of g in, into g by modulus of g. Okay, you can uh, write this equation similar to this one. Okay, so here you can take a dot product of these two vector and divide it by modulus of the vector g square and then g. So that's how you can find out the uh, vector component of vector f along another vector g. Okay, so let us come to the answer. So see here, I'm using the same relation that I have derived here. Okay, so by using this relation you can simply solve this uh, vector component. Okay, so as to find out the vector component of f that is parallel to the component g, vector component g, or say vector g, sorry, not vector component, it's a vector g. Okay, so this is basically the first part of this question, but the second part of this question is find out the vector component of f that is perpendicular to the vector g. Okay, so here you have to find out this component instead of this that you have already find out. Okay, this you have already find out by using this relation. So now second part of this question is asking this. Let me change the color. So here you have to find out this component. Okay, so for finding out this normal component, what you will do, you will simply subtract the vector f with the parallel component. So if suppose this is the parallel component of vector f, so you have to subtract this component with the vector f, so as to find out the normal component or say perpendicular component of f which is perpendicular to this vector g. Okay, so once you find out this parallel component, you have to simply subtract this parallel component with the vector f, so as to find out the orthogonal or say normal or say perpendicular component of f which is perpendicular to the vector g. So that's how you can find out the parallel as well as perpendicular component of any vector along some other vector. Okay, so the third part is somehow related to the second, first and second part. So here you have to find out the vector component of g that is perpendicular to the uh, vector f. Okay, so this you can find out by yourself, because we have seen in these two parts that how to find out the vector component of any vector along some other vector. Okay, so if you have any doubt in this question, then please ask. Anushka, do you have any doubt?
No, no, sir, no doubts.
Okay, so here is the next question. So here it is given that show that point P1, P2 and P3 lie on the straight line. Okay, so if suppose P1, P2, P3 is given to you, point is already specified here, which is equals to 5 comma 2 comma minus 4 for P1 and 1 comma 1 comma 2 for P2 and minus 3 comma 0 comma 8 for P3. Okay, so you have to check whether these points lie on the same line. Okay, whether it is lie on the same line or not. in a straight line or not. Okay, so this is the first part of this problem, and once you determine whether this lie on this straight line or not, the second part is determine the shortest distance between this line to some point. Let us say this is point p4. So you have to find that what will be the shortest distance between this point and this line. Okay. So first of all, uh, let us see whether this how to check whether these 3 points lie on the straight line or not. Okay, so for finding out whether these points p1, p2 and p3 lie on the straight line or not, you have to first determine, let me change the color. You have to first determine this vector which represents the vector from p1 to p2, and then you have to take another vector here. Okay, that is p1 to p3. Okay, so if suppose this vector p, let us say p1 p2, that you can find, okay, as uh, p2 minus p1. So p2 is already given to you, that is 1 comma 1 comma 2 minus 5 comma 2 comma minus 4. Okay, so you can find out the value of p1 p2, and then you can find out the value of p1 p3. Okay, so that's how you can find the another vector which is given as, so uh, this will be equals to p3 minus p1. Okay, so this will be equals to minus 3 comma 0 comma 8 minus 5 comma 2 comma minus 4. So that's how you can find these two vectors which I've shown here. And after that, for finding out whether these points lie on the same line or not, you have to take cross product of these two, that is p1 p2. You have to take cross product as p1 p3. So if this cross product will be 0, then you can say that these two lines lie on the same straight line, or say you can say that these 3 points lie on the straight line. Okay, so that's how you can determine whether the points lie on the straight line or not. And once you will find out whether if suppose this 3 points lie on the straight line, then for finding out the shortest distance between this line and this point p4, you what you will do, first of all, let us or say that we will determine once we find out this whether this point lie on the straight line or not. So let us directly come to the answer. So first of all, I am determining the this vector that that is lie between p1 and p2. First I am determining this vector, and after that I am determining this vector p1 p3, and then I will take the cross product. So once you take the cross product, you will see that this basically uh, comes to 0. So this represents that these 3 points lie on the straight line. Okay, so once you you find out that these 3 points lie on the straight line, then for finding out the shortest distance, which is the perpendicular distance of uh, this point and this line. Okay, this represents the shortest distance, which is equals to d here. Okay, so for finding out this shortest distance, what we can do, we can first uh, yeah, we can first find out the value of unit vector. So here is the unit vector of uh, unit vector along this direction. Okay, and we will then find out the vector which represent p1 p4. Okay, so once we will find out these two, what we will do, we will take cross product of these two so as to find out the shortest distance between these 2 points. So like here you can see that uh, I am taking the cross product of these two, that is the vector between p1 and p4, and then the unit vector from p1 to p2. Okay, and after that I am determining the value of shortest distance between these 2 points, sorry, point and the line. So any problem in this question, Anushka?
No, sir, no problem.
Okay, so the next problem is we have to express, if suppose this is a point given to us in the Cartesian coordinate system, then we have to represent this point in cylindrical and spherical coordinate system. So as we all know that usually three different coordinate system we are using for analyzing any system, that are Cartesian coordinate system. So for representing the any point in Cartesian coordinate system, we take x, y, and z as the parameter, whereas in the cylindrical coordinate system, we will use the parameter rho, phi, and z. Okay, and for spherical coordinate system, we will use the parameter r, theta, and phi. Okay, so in this question, this Cartesian coordinate point is given to us, and we have to find out the point that represent in cylindrical coordinate system and spherical coordinate system. So here I am trying to give you a concept that how you can easily find out the value of this point in cylindrical coordinate system. The is For spherical coordinate system you can analyze it by yourself. So let us suppose this is my Cartesian coordinate system, that is x, y, and z. Okay, and let us say this is the point. Okay, this point represent p, which is equals to 1 comma minus 4 comma minus 3. Okay, so for determining the value of rho, phi, and z, what we will do, oh sorry, uh, let me redraw the this in this again here. So if suppose this is the Cartesian coordinate x, y, and z, and this represents the point p. Okay, so first of all, for finding out the value of rho, phi, z from this Cartesian coordinate point, what you have to do, you have to first resolve this point in the xy plane. So here, yeah, so this represents the rho. Okay, and this represents the phi, whereas this distance z. Okay, so for finding out the value of rho, what you have to do, if this is the x and this is the y, for finding out the value of rho, what you have to do, you have to uh, take square root of x square plus y square. So if this is x and this is y, okay, so you have to take square root of x square plus y square. Whereas for finding out the value of phi, which is the angle here, okay, what you have to do, if this is y and this is x only, then you can say that tan of phi represent y by x. So phi you can find out as tan inverse y by x, okay, and z will remains the same, which is same as the z of the Cartesian coordinate system, okay. So here z will be same as -3, whereas rho you can find out as 1 square plus 4 square, which is equals to root over 17, and phi you can determine as tan inverse, yeah, this will be -4. Okay, so that's how you can determine the value of rho, phi and z. That is the same point there, which is representing in the Cartesian coordinate system. The same point is representing in cylindrical coordinate system. So that's how you can determine the same point. Similarly, you can find out the value of spherical coordinate system by yourself. Okay, so I am giving you a hint, like here let us suppose x, y and z is given to you, and this represents the point P. Okay, so this represents the R. Okay, whereas once you take the projection of this point in xy plane, so this represents the phi, and angle from the z axis represents the theta. Okay, so for finding out the value of r, what you have to do, you have to take square root of x square plus y square plus z square. So that's how you can find out the value of r. Whereas let us uh, take this phi as this is x, this is y, then phi is same as the previous case, that is in cylindrical coordinate system. So phi is represented as tan inverse y by x, and for finding out the value of theta, what you have to do, you have to take this z, and this is equals to, yeah, this is equals to rho, or say, 1 minute, yeah, so this is equals to x square plus y square in root. Okay, so theta is given as tan inverse rho by, yeah, so this will be equals to rho by z. So that's how you can specify the same point in the spherical coordinate system. So I've already given the answer here. You can match this solution, that is answer given to you by yours after solving it by yourself. So if you have any doubt that in this question particularly, then you can ask. Okay, so let us move ahead. So our next question is, express the vector field H which is given to you in cylindrical and spherical coordinate system, and once you have represented this vector in cylindrical and spherical coordinate system, then you have to determine the value of H at this point. Okay, so see, this vector is already specified to you in Cartesian coordinate system. So for finding out the value of h at this point, you have to directly put the value of x as 3, y as -4 and z as 5 here. So that's how you can determine the value of h at any given point Okay, whereas in the first part we have to first convert this vector h in the cylindrical and spherical coordinate system. So how to do this, that is the question. So for finding out this, let me first draw the coordinate system. So let us say that this is the coordinate system here. Okay, this is x, this is y, and this is z here. Okay, and this represent the point P. Okay, yeah, so we can take the projection of this point in xy plane, and this represents the row. And if suppose I am drawing a circle here, going passing through this point. Okay, so the unit vector along r is defined as ar cap, which is radially outward here. Okay, the phi, as you know that phi is represented it here, that is started from x and going towards y axis. So the unit vector of this point along y is along this direction, that is a phi, and z will be along this direction, this will be az. Okay, so let me change the color. Okay, so this is given to you. So what you have to do, yeah, you have to take the projection. So let us say that yeah, so here this will be 90 degree and this is phi, so this will be 90 minus phi, so this will be phi only. Okay, so here you can say that a row is defined as ax cos of phi minus, because here if suppose this is a phi, then you can resolve along y and x. Okay, so this will be, yeah, this will be plus and ay into sine of phi, and az will be 0 here because z is not in this plane, this is xy plane only. Okay, similarly you can phi a phi, so a phi will be equals to minus ax, because this is along the minus x direction, along the minus x direction. Okay, and this is equals to sine phi plus a y into cos phi, and z component will always be 0 here because this is in xy plane, and az will be equals to az only. So you can uh, represent this as a row a phi and az as cos phi sin phi minus sin phi cos phi. This is 0 0 1 0 0. Okay, and this will be equals to ax ay and az. Okay, so if this component along x y and z is given to you, that is given here, this is the hx, let us say x component of h, this is hy, that is y component of h, and this is the z component of h is given to you, then by putting these components here you can easily determine the components along rho phi and z in cylindrical coordinate system. Okay, so here you can see that I am using the same matrix, just I am replacing the hx, hy and hz component here. Okay, so after that I am finding out the value of hx. So sorry, h row is uh, cos phi into this, sin phi into this, and 0, this will be 0 only. So that's how you can find out the value of h row. So this basically represent in terms of x, y and z only. But as you all know that in cylindrical coordinate system, this uh, coordinate system can be specified in terms of rho, phi and z. So you can replace the value of x, y and z in terms of rho, phi and z. So x can be replaced it here as rho cos phi. So I am determining this x from this figure only. So if suppose this is rho, okay, so you have to take uh, the projection of rho along x. So this will be equals to rho cos phi, because cos phi is the angle between these two. And for y you have to take angle between these two, which is 90 minus phi. Okay, so y you can give it write it as rho sin phi, and z will be equals to z only. So you have to replace this x, y and z by using this expression, so as to find out the rho component. Similarly you can find out the value of phi component and z component. Okay, so that's how you can represent the this vector in cylindrical coordinate system. Okay, so similarly you can find out the uh, this vector in terms of spherical coordinate system. So here in spherical coordinate system the matrix will be different. So this is the basically the matrix that are used to find out the value of rho sorry r, theta and phi component in uh, spherical coordinate system. Okay, so you have to put it the x, y and z component here, and replace the x as r sin theta cos phi, y as r sin theta sin phi, z as r cos theta. Okay, so that's how you can find out. So in this, if you have any doubt in this question, then please ask. Anushka, do you have any doubts?
No, no, sir. No
Okay,
doubts.
okay. So this was the last question. So I think we can wind up this session here. Okay. So thank you.